So, a data warehouse with a giant, expensive relational database is not your only choice for a data management system for your organization. These days, in the world of big data, increasingly we're seeing organizations choose something called a data lake instead. And they might be querying that data in the data lake with something called a data lakehouse. Get it? Like instead of warehouse, it's a lake house. Yeah, we'll talk more about what that means. So, what do we mean by a data lake? So, the main thing that sets a data lake apart is that it can hold both structured and unstructured data. So, in a data warehouse, we have a very rigid data structure and schema that we're shoving our data into. This makes it very easy and efficient to query that data, but it does require us to structure that data ahead of time and store it in a structured manner. With a data lake, maybe I'm just throwing in raw data from its source. Let's take an example. So, let's say I have a massive website that has hundreds of web servers on it. And maybe I want to track the behavior of customers over time as they click on individual pages on my website. We call this clickstream data. So perhaps instead of trying to force this data into a structured database, I'm just dumping those raw server logs into a massive data lake. A concrete example of a data lake might be Amazon S3, for example, just a massive cloud-based data store that's basically unlimited in its storage capacity. So it's a lot easier and a lot more scalable to just dump those logs into one centralized, scalable place in the cloud. That's what we call a data lake. And it may or may not be structured. That's the main thing that sets data lakes apart. So I might just be dumping in raw server logs that have no structure to them at all, or maybe I'm imparting a little bit of structure to them in the process of transporting them to the data lake. You can imagine a system where on the servers, it's massaging that data a little bit and extracting the data that it needs and structuring it in some file format like JSON or something, and feeding that into the data lake in a semi-structured format at least. The data lake itself does not require it to be structured, but giving it a little bit of structure will make it easier to query. So what do we do with that data once it's in the data lake? Well, you could copy that data into an actual data warehouse and have a structured copy of it somewhere that is loaded up on some batch manner, but you don't actually need that intermediate copy at all. Instead, we can use what's called a data lakehouse to actually query that data in place on the data lake. So how does that work? Well, if your data is structured already when you dump it into the data lake, then it's actually fairly straightforward. I can query that data in the data lake and use that structured information to extract the fields that I care about. And maybe there's some intermediate process that builds up a schema and some table and maybe some offline files to accelerate those queries automatically. But fundamentally, we are not duplicating the data in the data lake in order to query it. There might be some structured data, some schema data off on the side that's been built up, as that data is received, but the data itself is not copied. And when you're dealing with massive data sets, that can save you a lot of money in storage costs, and it's one less thing that can go wrong, right? So that's the main benefit of a data lakehouse. It combines the best of both worlds. So you're getting all the flexibility of a data lake and the cost effectiveness of a data lake, but you can still conduct queries across the entire data set just like in a data warehouse. This isn't something you need to know for the exam, but I like to give you a concrete example. One might be Amazon's Redshift Spectrum product, where it allows you to treat underlying data in an S3 repository just like it were a data warehouse. So it can make raw data sitting in a data lake look just like an actual data warehouse that's been carefully curated somewhere in a very expensive manner. So just to recap, a data lake is a giant repository for your data, and it might not be cleaned yet. It could be still in a very raw, ugly form within the data lake, very, very much different from a data warehouse where everything's been scrubbed and cleaned already. And a data lakehouse allows us to query that data in place within the data lake, where we can treat it like a data warehouse, but in reality, it's potentially only semi-structured data under the hood, or maybe even unstructured. And the data lakehouse tries to impart structure on that data and allow you to query it in place. These data lake and lakehouse approaches can be more scalable when you're dealing with truly massive data sets than a data warehouse, and less expensive as well. Whether your organization chooses to use a data lake and lakehouse or a data warehouse will probably be up to your IT department. But from your standpoint as a data analyst, either a data lake and lakehouse or a true data warehouse can be used to analyze large amounts of data. And oftentimes you'll find lakehouses used in contexts where you're not just doing analysis of data, but also using that data for machine learning or data science purposes. The world of data science and machine learning very frequently uses data lakes and lakehouses, as a lot of their tools are really geared around that technology.